All right, welcome back. 11-4. We're going to do double and half angle identities, kind of like double Jeopardy. That's what made me think. Yeah, it's a bit of a reach. I'm sorry. So we're going to play a little Jeopardy, which is going to lead me into probably one of my favorite Saturday Night Live skits ever at the end, Celebrity Jeopardy. So you have something to look forward to. So let's get to it. The first answer is sine of 2x. What's the question? Well, okay, it's not really a question, but let's take a look here. If we can find the sine of 2x. Now, you did this already in the extension and application. Sine of 2 theta is the same thing as saying sine of theta plus theta. All right? So I'm going to use my sum formula. All right? And we know that sine of two things I'm going to add together is sine of theta, cosine theta, plus sine of theta, cosine theta. Now, normally these are different, right? Well, in this case, it's the same thing, which is actually very nice because now I have two of the exact same thing. So I have two of these sine theta, cosine thetas. And in fact, that is going to give us our double angle formula. So for example, when we're working with something, if I tell you that theta is here, we now can use our formula and we will essentially double that and it'll give us that. We won't have to know the exact answer. We can use our formula. We can know the exact one for theta and find double theta. That's the reason it's so nice. Wouldn't it be great if we had something for, I don't know, cosine of 2 theta? And yes, I agree, it would be amazing. So let's try one for cosine of 2 theta. So we know that is going to be, we'll draw a little squiggly line here. Let's see what we can do. Cosine of 2 theta, that's the same thing as saying cosine of theta plus theta. So what's my sum formula? Well, that is the cosine of the first angle times the cosine of the second angle. In this case, it's the same thing, right? Minus sine of the first angle times sine of the second angle. And again, that's the same thing. Well, we have two of that. That is going to be cosine squared theta minus sine squared theta. Oh, come on. So there we have it. Cosine of 2 theta, our double angle formula for 2 theta, or cosine of 2 theta is cosine squared theta minus sine squared theta. Now, the great thing about cosine is it actually does have a couple other ones, and these will come up nicely when you have, for example, identities to prove. All right, so there's one. It also equals 2 times cosine squared theta minus 1, and of course, then it would also be 1 minus sine squared theta. Whoops, totally made a mistake there. That should be 1 minus 2 sine squared theta. Not 1 minus sine squared theta. Again, 2 in front of the sine squared theta. Totally my fault. Sorry about that. All right. So these are also legitimate cosine 2 theta angles, but this is the one I'm going to use the most. All right. It's going to get most play for us. All right. And let's see here. That leaves us last, but certainly not least, we have tangent theta. All right. So tangent theta. This is of 2 theta, that's going to be tangent of theta plus theta. Use our tangent sum formula, so that's tangent of theta plus tangent of theta. Divide that by 1 minus tangent of theta times tangent of theta. I have 2 of these, so that's going to be 2 tangent theta over 1 minus tangent squared theta. So there you have it. Now you have all your double angle formulas, anything you could ever ask for, right? To your heart's content. Well, let's put this to good use. So example number 1, if cosine of theta equaled radical 5 over 5, and we're in the first quadrant, find the exact value of each function. So the first thing let's do is draw this reference triangle. This is theta. And we know that cosine of theta, so radical 5 over 5. It would certainly be nice if we had this sine value here, so let's find that. 5 squared equaled y squared plus radical 5 squared. So that's 25, and I'm going to bring this over. Minus 5 equals y squared. 20 equaled y squared. So the square root of 20 is 4 times 5, which is 2 radical 5. All right. So we now know that this sine component here is going to be 2 radical 5, our y value. So let's find sine of 2 theta. Again, our double angle formula is 2 sine of theta times cosine of theta. Now remember, I'm going to plug in here some values. I'm not plugging these into my calculator. When I find sine theta, I know that's opposite over hypotenuse. I know that is 2 radical 5 over 5. I'm not plugging sine of 2 radical 5 over 5 in my calculator. That is not how you do this. You have found sine of 2 theta. It is 2 radical 5 over 5. Likewise, cosine of theta is radical 5 over 5. All right? So you got to be careful there. So let's see. 2 times 2 is 4. So we got 4, and then radical 25. The square root of 25 is 5. 5 times 5 is 25. So we have 20 over 25, which reduces to 4 over 5. All right? That's that first one. Let's come over here and look at cosine. So our cosine formula is cosine squared theta minus sine squared theta. So cosine squared theta, we know, is radical 5 over 5 squared, minus sine squared theta is 2 radical 5 over 5 squared. So radical 5 squared is 5 over 25 minus 2 squared is 4. Radical 5 is 5 over 5. So now we have 5 minus 20 over, 25. That gives us negative 15 over 25, which is negative 3 over 5. Okay? So we found our cosine 2 theta and sine of 2 theta. Ooh, the next thing we want to find is cosine of x over 2. So we've done double angle, but what about half angle? Mr. Bruss, why don't you take this one?
Well, if I'm going to give you some kind of angle, maybe I give you this angle here as alpha. And what are we going to do with it? We are going to cut it in half. We're going to say, well, what happens when you cut that in half? So if that big angle was alpha, this will be alpha over 2. So we're going to cut it in half. So we're going to find exact value. So if maybe you're interested in the sine value of the big angle alpha, now I'm going to find the sine value of alpha over 2. So to do this is essentially the double angle identity. Instead of doubling angle, I'm cutting it in half. So we're going to need those double angle identities. So we're going to need, the double angle identity said cosine of 2 alpha equaled what? It was cosine squared alpha minus sine squared alpha. And what was good about that is you could rewrite this a couple different ways. And the couple different ways we could do it. We could do 1 minus 2 sine squared alpha, or we could do 2 cosine squared alpha minus 1. So a couple different ways to do this. So now I'm going to have these, and I'm going to come up with our new ones. So let's go about coming up with our new ones here. And ideally, what's this going to look like? I'm going to take an angle like maybe I'm going to tell you the angle alpha is 150. And I want to know what is, that's on my table. I can use my unit circle for that. What's the exact value? Well, if I cut that in half, I'm looking for, what's the half angle? What is it? The sine value of 75, not on the table. So we can use this. So let's come up with our formula. So it's actually not too bad. Let's start with cosine. If I got cosine of 2 alpha equals 2 cosine squared alpha minus 1. So this is the normal double angle. All I'm going to do is change one little thing here. I'm just going to call cosine, the 2 alpha, I'm going to replace it with theta. So it's the same thing. I'm just calling it this, just changing it to theta equals 2 alpha. The reason I did that is now what do I call alpha? Well, if this is 2 alpha is twice as big as this is half as big as this. So this is theta over 2. So here is my new equation right here. So really in this, theta essentially equals 2 alpha. And now it's just a matter of simplifying. I want to get cosine squared by itself, so I can go ahead and get cosine squared by itself. How do we do that? Well, let's add 1 to both sides. And we've got theta plus 1 equals 2 cosine squared theta over 2. Now what do I do to get this? I want theta over 2 by itself. I'm going to divide by 2. Divide by 2. Well, so that's pretty good. So I'm left with what? Cosine. I'm going to flip it over here. Cosine squared theta over 2 equals cosine theta plus 1 over 2. What's the last thing I have to do here? Well, I don't want cosine squared. I want cosine, so I'm going to have to square root both sides of this. So whatever I do once I do that, so that'll cancel. I'm left with, ooh, I better make this look pretty. This is the finale. So maybe you're just sitting back waiting for it. That's okay, enjoying the ride. This is cosine theta over 2 equals what? It equals, I need some more room here. No, don't move that. Oh man, wrong thing. Let's try this. So that's going to equal, what happens when you introduce a square root? Remember, it becomes plus or minus. So it's plus or minus. We have cosine theta plus 1 all divided by 2. So that is our half angle identity for cosine right there. And the key to this is we're going to choose the plus or minus. Very interesting. All has to do with what quadrant you're going to end up in. Just like I started in quadrant 2, I ended in 1. So I'm going to have to choose what is the cosine value over there. So that is our first one. Let's go ahead and see if we can get sine. Sine, I'm going to do the same thing, but I'm going to use this identity right here. Let's take that over to the next page. And let's go ahead and put this up. Here is the cosine one. I'm looking for sine. So to get sine, I'm still going to use the cosine of double angle identity. In this case, I'm going to use which one? I'm going to use the sine. So 1 minus 2 sine squared and of alpha. And again, the trick to this one is I'm going to put theta in there for cosine. So that is the whole trick to that. And then what is this? This is going to be half of theta to make it work. So now it works. And now I want to get sine squared theta over 2 by itself. I'm trying to get that theta over 2 by itself. So to do that, I'm going to what? Let's go ahead and subtract 1 from both sides. So we've got cosine theta minus 1 equals negative 2 sine squared over this. And what am I going to do here? I'm going to divide by negative 2. Divide by negative 2. And what happens here? Well, I'm going to bring that negative on top. It really becomes negative cosine theta plus 1 all over 2. And those cancel, and I'm left with sine squared equals theta over 2. Again, maybe you're just holding out for the finale. Here it comes. What do I do to both sides? I got to square root it to get it by itself. And I'm going to flip it so it looks a little bit prettier. We've got the sine of theta over 2 equals, remember, plus or minus. And I'm going to change this. Instead of minus cosine plus 1, I'm going to go 1 minus cosine theta all over 2. There it is. That is the other half angle identity. Boom. So there they are right there. Fantastic. Pretty cool, huh? So there's two of them. Can we do tangent? Sure, we can do tangent. Let me get rid of all this. To get rid of tangent, I know sine and cosine, so it's again back to our identities. Just expand this. If I'm looking for the half angle of tangent, what is that? It's going to be the half angle of sine over the half angle of cosine. Pretty cool. So really just plug all that mess in there. I'm going to have the sine is the square root of 1 minus cosine theta over 2 all over, what's the cosine? The square root of 1 plus cosine theta over 2. Luckily this breaks down. That looks awful, but it's not too bad. Remember, if I wanted to, I can just put the square roots over everything, the square root top and the bottom. And check this out. What else is cool here? They have the same thing. It's a fraction of fraction, but the denominators are the same, so I can just cancel that out. And I'm looking at 1 minus cosine over 1 plus cosine. And what's good about this? I'm going to throw in the plus or minus. So really, there it is. The tangent of theta over 2 equals, can I bring this guy over? We better bring a square root with him. Bring that over too. Oh, there it is. Awesome. Fantastic.
Thank you, Mr. Bruss. So these are our half angle identities. Make sure you write those down, have them good and clear. We're going to have to make choices plus or minus based on what quadrant these are in, right? Alright, so let's take a look. Let's try one out here. So find the exact value of each. Alright, well, this first one, sine of 22.5. Is that not the same thing as sine of 45 over 2? It is indeed the same thing. So we're going to use our half angle sine formula here. So we're going to come down, plus or minus, we'll worry about that in a second. That is 1 minus cosine of 45. You plug in the angle that you would divide by 2, not 22.5. All right, we come down here, and then we're going to divide it by 2. So let's take a look. Cosine of 45 is 2 radical 2, or radical 2 over 2. So it's 1 minus radical 2, over 2. Divided by 2. So now we need to get a common denominator. We'll do 2 over 2. So this is 2 minus radical 2 over 2. All of that divided by 2. Fun fraction times, right? This is essentially just going to be 2 minus radical 2 over 4. All right, now we're going to leave it just like that with a radical and a radical, even though that's kind of, strange looking. Now we need to determine what is this positive or negative. So we're dealing with sine 22.5. That's in the first quadrant. Since it's in quadrant number 1, right? Quadrant number 1, sine is the y component. That means it's going to be positive. So this is positive 2 minus radical 2 over 4. All right. Let's come over here and try cosine of 7 pi over 8. That's essentially the same thing as cosine of 7 pi over 4 divided by 2. So I'm going to use 7 pi over 4 divided by 2. Plug that in my formula. Again, my formula is going to be very similar. It's going to be 1 plus cosine of 7 pi over 4. All of that divided by 2. We'll find the plus or minus here in a bit. So now let's plug these in. So that's going to be cosine of 7 pi over 4, I believe is just radical 2 over 2. All right. So let's take a look here. Common denominator, we need a 2 over 2 again. So this is now going to be plus or minus 2 plus radical 2 over 2, all that over 2, which gives us plus or minus 2 plus radical 2 over 4. All right, so now we just need to worry about, is this positive or negative? All right, let's take a look. This is 7 pi over 8. 7 pi over 4 is the same thing as 315, right? Divide that by 2, that's going to give us 157.5. So that's in quadrant 2. And in quadrant 2, cosine is negative. So this is going to be negative radical 2 plus radical 2 over 4. All right, so if sine of theta equals 5 over 7, and we're in the second quadrant, find the exact values. Let's draw our reference triangle first. So this is 5 over 7. We should probably find our x value. So that's going to be 49, 7 squared, equals 25 plus our x squared. So that's going to be 24 equals x squared, and that simplifies down to 2 radical 6. All right? So this is negative 2 radical 6 because we're in the second quadrant. All right? So what I would like you to do is pause the video and try and find the double angle of this and the half angle, and then take a look at your answers. All right, over here we have our double angle formula. We plug in 5 over negative 2 radical 6. 5 over negative 2 radical 6. Have some algebra to do here. The 2's cancel, we're left with negative 5 radical 6. Subtract 1 minus that, we get negative 1 over 24. Multiply by the reciprocal, we get 120 over radical 6. We have to rationalize the denominator, so 120 radical 6 over 6, and then divide by 6, we get 20 radical 6. Over here, we have our plus or minus 1 minus cosine theta, 1 plus cosine theta. I plug in my formulas, have to get a common denominator, so 7 minus a negative, so that's 7 plus 2 radical 6 over 7, and 7 minus 2 radical 6 over 7. Essentially, the 7's are going to cancel it out because we multiply by the denominator, so we have 7 plus 2 radical 6 over 7 minus 2 radical 6. Multiply by the conjugate of the bottom to get rid of the radicals. We get 49 plus 28 radical 6 plus 24 over 49 minus 24, which simplified gives us 73 plus 28 radical 6 over 25. Square root of the top, which we can't really do. Square root of the bottom is 5, and it's positive. Why? Oh, why is it positive? Let's take a look. We are between 90 and 180, so if we are doing half of that, we are between 45 and 90. When we're in the quadrant 1, quadrant 1 for tangent is positive. Quadrant 1 for tangent is positive. That's why we're positive for that one. All right, so check that out. All right, so we're going to do some verifications here. All right, the most complicated side to me looks like the right-hand side, so I'm going to start with that. I'm going to move this over a little bit so we have some more room. I know that the sine of 2x, I have a formula for that. That's the same thing as 2 sine of x cosine of x, our double angle formula, right? I also have a formula for cosine of 2x, one of those that we didn't use a whole lot of, but I remember at the beginning of today I gave you this second one. Cosine of 2x is also the same as 2 cosine squared of x minus 1. All right? Now we're going to try and get cotangent x, which we know is cosine over sine, right? All right, let's take a look. 2 sine of x cosine of x. To me, this looks like I can distribute, so I have 1 minus 2 cosine squared x plus 1, which gives me 2. So now I have 2 sine of x cosine of x, and 2 minus 2 cosine squared of x. Anytime I see the same number down here, I like to factor. Haven't done a whole lot with the top. So this is 2 times 1 minus cosine squared x. All right. Those 2's are going to cancel, all right? So now what do we have? Well, 1 minus cosine squared x is the same thing as sine squared x. So this is sine x cosine x over sine squared x. And this will cancel out with that, so now we're left with cosine x over sine x, which is cotangent x. And that's what we wanted. All right, that's a pretty long one. Totally understand that. Not terribly difficult. Mostly the trick is here using the formula that we haven't used a ton of. All right, but it's right there. So what I want you to do is I want you to try this one. It's pretty detailed. I'm not going to lie to you. I'll give you a hint. I want you to multiply by a conjugate, and I want you to sub in the formula on this side. You're going to do a little bit on this side, you're going to do a little bit on this side, and then have them equal halfway down. All right, so try that one. All right, so let's take a look at this. I'm going to do the right-hand side first. All right, so the first thing I did was I multiplied by the conjugate of 1 minus cosine x, so it's 1 plus cosine x, top and bottom. I can do that because this is just 1 and it doesn't change anything. So 1 minus cosine x times 1 plus cosine x is 1 minus cosine squared x. Notice I just left the bottom. The reason I did that is because 1 minus cosine squared x is sine squared x, which we know. All right, now sine squared and a sine, they cancel out. This one on the bottom is going to cancel out with 1 on the top, so I have sine x over 1 plus cosine x. Now I'm going to stop there and I'm going to go to the other side. All right. Now again, I'm going to multiply by a conjugate, this time on the top, and it's got to be inside the radical because this is inside the radical. The only way I can multiply things are if this is in the radical, I got to multiply this by a radical. So this gives me 1 minus cosine squared x, and on the bottom I have 1 plus cosine x times 1 plus cosine x, which is just 1 plus cosine x squared. All right, I don't need to multiply that out just yet. 1 minus cosine squared x, again, same identity as we did over here. That is sine squared x. Now here's the great thing. The square root of a square is sine x. The square root of 1 plus cosine x squared is 1 plus cosine x. And then notice we have exactly the same thing on the left and the right. And that's a new strategy, I know. Haven't done a whole lot of those, but you can. Work on the right, work on the left, get them to equal at the bottom. All right, so I'm going to leave you with a little clip of Celebrity Jeopardy. It's one of my favorite Saturday Night Live skits. It mocks how dumb these celebrities actually are when they get on Jeopardy. I think it's pretty funny. Hope you enjoy it, and I'll see you on the flip side.
We've got a real barn burner on our hands. In the lead, we have Kathy Lee Gifford, a first-time player.
Hey, who you calling a player, G? G? What's that mean, Grandpa?
And you have negative $22,400. In second place, with negative $46,700, is Tom Hanks.
I am a slow starter, Alex, but I...
States that end in Hampshire. What color is green? And current black presidents. Let's just move on to Final Jeopardy. The category is nonsense words. Just write a random series of letters, any letters, as long as it's not a word. You will. Tom Hanks, you managed to give yourself a pretty nasty welt there. Let's see what you wrote. And you broke your podium.
You see what happened was...
Okay, again, that's a pen, that's not a microphone. It's not a microphone.